Welcome everyone. Now I'm going to discuss about Bayes' theorem, which is a very powerful tool to update probabilities with new information. Before that, let me introduce myself. I'm A. Satya Abhinay. I'm from EC branch and my roll number is 403. Now, the agenda of today's topic is to find the foundation for the Bayes' theorem, introduction for deductive analogy, Bayes' theorem formula will be explained, and then for the clarification, I will give an example using a medical test and its calculations, and then we'll discuss the important points and its applications, and then we'll conclude the session. Now, beginning the topic, before beginning the explanation of Bayes' theorem, now I want to explain about conditional probability, which is a foundation for the Bayes' theorem. Conditional probability is the chance of an event happening given that another event has already occurred. That means, suppose consider an event A. Event A is already occurred, and then the question will be, what is the probability of event B given that probability of event A? Bayes' theorem builds upon this concept. Understanding conditional probability helps grasp how Bayes' theorem works practically. After that, introduction with the detective. Consider you as a detective. Now you are solving a case to find a criminal. So now you got a dilemma. There are no clues right now to conclude who is the criminal. Now, what will you do is you will search for the new clues and revise the old clues. You update these suspicions logically, by which is a part of Bayes' theorem. This relates to the Bayes' theorem practically. The Bayes' theorem provides the mathematical framework for updating beliefs or probabilities based on new evidences. I mean new events. Answers the questions like, given this event, what is the chance of the happening an event B? So let's continue in this topic. Bayes' theorem formula. Consider an event A and a sample space S. Uh, Consider event A in the sample space S, and then let B1, B2, B3, and so on Bn be the events which are mutually exclusive and exhaustive. The formula for this Bayes' theorem is P of Bn by A. That is, from this we can say that the conditional probability P of Bn by A, probability of event B given that A is already happened, which is equal to probability of Bn into probability of A given Bn divided by probability of A. So this is the formula for the Bayes' theorem. So the Bayes' theorem calculates the probability of event B given the event A. Explanation of terms. Now I will explain the terms included in this formula. Bn, a possible cause or the event which we want to find its probability. A, an observed result. The event that is already occurred. P of Bn, probability of the event, prior probability we will call it as. P of A by Bn. Bn is already occurred. P of Bn by A, which is a reverse to the previous one. We will call it as posterior probability. How likely Bn is given that A is already occurred. The last, P of A. Total probability of A using all the ways A can happen through B1, B2, and so on Bn. Next, discuss it with an example. Consider there are 100 people. In that, 10 of them are very sick. Now, let us conduct a medical test to those. If they are sick, 80% of the chance that test shows positive. That means if the 10 in those 100 people, if the 10 of them are very sick, then the results of them will be positive, and this got to be the 80% chance. And if they are healthy, but also they will get a positive, which is a wrong test case, and that's probability will be a 10%, which is a very minor compared to the 80%. Now let us imagine one of your friend took the test and he got the positive result, and but you know this, he does not have any virus or something, but he got the positive. Now the question is, does that mean your friend is surely sick? No. But because healthy people can also get wrong positive result, there will always be some uncertainty when doing these type of tests. There will not always be 100% accuracy. We shall calculate this to understand very better. Given that the total people that took the test are 100 people, 10 of them are very sick. That means probability of sick equal to the number of events by total number of events. That is 10 by 100, which gives 0.10. Now let us calculate the probability of your friend being positive. Uh, given that, I mean, let us let us calculate the probability of the 80% of the people who got positive, given that they are sick. That gives 80 by 100, which is equal to 0.80. And now let us calculate the rest of the people, that is, who are not sick but got 10%, but got positive result. That probability is given by P of positive by healthy is equal to 0.10. Therefore, 90 people are healthy, so their probability would be 90 by 100, 0.90. Step 1. In order to calculate, we need to find the probability of people who got positive. The total chance that someone sick or healthy tests positive. That means no matter you are sick or healthy, the chance of you getting a positive result is given by P of positive, which is equal to probability of being sick in addition with probability of getting positive given that you are sick, with in addition with probability of getting positive given that you are healthy. By calculating this, we will get the probability of the people who are getting positive, regardless of their condition, that is sick or healthy. Now let us use the Bayes. From the Bayes theorem formula, we'll calculate the probability of the uh, people who got sick. People who are sick, given that they are positive, by sick into P of sick divided by P of positive. Now, by substituting the above values in this formula, we will get approximately 0.47, which is equal to 47. From this, we can interpret that if your friend's test is positive, there is about a 47% chance that he, and the rest, that means 100 minus positive, which is 53%, that is the test is pretty accurate. From this example, and we will discuss the key insights. That means we'll discuss the important points of the Bayes theorem, the importance of the Bayes theorem. Here are the a positive test results does not guarantee sickness because false positives can occur, especially if the disease is rare. Not everyone who tests positive actually has the disease. That means even though how accurate your mission can be, there will always be some uncertainty which gives you a doubt of wrong results. If the disease is very rare, then that probability of getting wrong result will be less. And if the disease is, we actually use Bayes theorem, which is used to correct misunderstandings. It adjusts the gut feeling that a positive test means almost certain disease. You can also think that if your friend got positive, you may think that he is really sick, but which is a gut feeling. But by using Bayes theorem, you can conclude that that is not very true, and you should not trust your gut feeling every time. Now, Bayes theorem is very crucial for decision making. Instead of gut feeling, when we use Bayes theorem, we will get the more accurate answer. Understanding these probabilities helps doctors, engineers, and scientists make informed decisions. From this point, you can understand in every industry, this theorem is useful, which is used to conclude some results about the uncertain information. Now, we'll discuss about the applications of the Bayes theorem. Medical diagnosis. We use Bayes theorem to calculate real probabilities of illness after a test result. Just as we seen in the previous example, in medical industry, we use the Bayes theorem to calculate the real probability of the person being really sick, correcting for false positives and disease rarity. And we also use this in weather forecasting, such as we use this to update predictions by combining new data with comparison with the past data. Uh, Now in our apps, in phones, there are many apps which shows the weather conditions. Theorem is used in those apps which can conclude most accurate data. We also use this in weather forecasting, and then we use this in spam filtering that too. Spam filtering means there are many mails we get which are spam, which could cause us many losses. So Bayes theorem is used to filter them, and it is used to detect them and filter them and show us which are spam, which are good. That is that email system use Bayes theorem. Finally, these are also Bayes theorem is also used in DNA and forensics. Helps interpret DNA, test evidence in criminal cases, giving a probability a sample matches a suspect. Bayes theorem is very crucial in all these aspects, whether it can be forensics, it can be spam filtering, it can be weather forecasting, and it can be in medical industry. We can conclude this session here by discussing the summary of this presentation. The Bayes theorem is a very powerful tool to update beliefs and make better decisions using new evidence. As we discussed, this proves the point. It is widely used whenever uncertainty, evidence, and probabilities must be combined in medicine, technology, and or in our daily lives. It can be used in every industry or every aspect of our lives. It can be used in our daily lives, which gives us some accurate information about the things we want to calculate or get information about. Real world decisions, big or small, are improved when probabilities are updated with Bayes logic. No matter how big or small the question is, where to get the accurate result, we need to use probabilities in with Bayes logic in order to get the result accurately. Let us conclude this session here. I'm very thankful for hearing this presentation. Thank you.